Question says that figure 2.11 shows xt plot of a one-dimensional motion of a particle. Is it correct to say from the graph that the particle moves in a straight line for t less than 0 and on a parabolic path for t greater than 0? If not, suggest a suitable physical context for this graph. So the question is trying to infer that does xt plot represents the trajectory of the path that the particle follows in a one-dimensional motion. The answer is no. Xt plot does not represent the trajectory of the path. So the time less than 0, the time axis, since it is 0 in the position scale, it represents that the particle was at rest, and it does not represent that the particle moves in a straight line for t less than 0. Instead, it was at rest. So particle was at rest at t less than 0, and for the time t greater than 0, we see a parabolic rise in the position of the particle with respect to time. So let's now find out the context of this motion. The position varies. Mathematically, we can say that the position, that is x, is directly proportional to the square of the time axis, and substituting here with a proportionality constant, position of the particle may be written as kt square, where k being the constant of proportionality. Now, if we try to correlate it with a similar motion of particle, the equation of a motion of a particle, that is s equals to ut plus half at square, and if we substitute u, that is the initial velocity, with 0, then the equation of motion in the given problem is very much equals to the equation of motion that we have for motion under constant acceleration. This will, after substituting u equals to 0, this will come out to be s equals to half at square, where this half a is constant, which may be substituted for k. Now, this constant motion under constant acceleration, if we try to find out an example for this, the perfect example where u is 0 and the particle is traveling under constant acceleration is when ball is dropped from a certain height. Let's say that h height. When the ball is dropped without any initial velocity, u equals to 0, then the motion of the particle is under constant acceleration, and it varies with this. The position can be computed with this equation. So we can say that the context representing the graph is trying to represent the context of a ball falling with the initial velocity of 0, and also the position coordinate is taken 0 over here, and x direction, positive x direction, is assumed in the downward direction of the ball. That's why it is 0 over here, and it is rising as the time progresses. So x is positive in this downward direction. Thank you.